Okay, boleh nampak. So this is called instant-based classifier. The other, they call it K nearest neighbor. So they are looking at the nearest neighbor. If they get new instant, they will get the nearest resemblance entity or item with respect to the new item. So they will assign the label of this nearest neighbor to the new new sample in your dataset. Okay. So the key concept that we need to understand here is the instant base, and also we look at how do we measure the similarity between two example or two instant, and then how do we apply this nearest neighbor in order to do some classification. Okay, so these are the three main concept or the main idea that we need to know about instant-based classifier. Okay, so nearest neighbor classifier are defined by their characteristic of classifying unlabeled example by assigning the class of similar label example. So basically, they are using the label of the nearest neighbor or the nearest sample that match the new item that we have. Okay, so this can be used for optical character recognition, facial recognition, prediction whether a person will enjoy a movie or music, pattern in genetic data. So basically, if you have a new item here, okay, so you will look for the nearest neighbor. So for example, if you have this and this, oh, the nearest neighbor will be this one lah. So let's suppose the label for this one is A, class A, this is class B. Okay, since this new item is nearer to this particular neighbor, so they will take this A and then they will assign this one as A as well. Okay. Okay. So sometimes if the concept is difficult to define, but you know that it can be see it, then nearest neighbor might be the most appropriate classifier, because basically they are looking at similarity index, how similar two items are together. Then they will assign the label of the data that we have in our database into the label of the new item that we have. Okay. Okay. So the key idea is that we will just store all the example. So you have all the example, and this is the mapping to the label. So this is label. Okay. So this is your data or your instant. So setiap instant too, they will have their own label. Okay. So the idea of the nearest neighbor is we want to know how similar this new item. Okay, this is new. Okay, this is the data that's stored in the database. So this is the old data. Okay, so given query instant XQ, given this, we want to know what is the label. So what we can do is we can first locate the nearest training example, which is this, and then we assign the label back to the query instant XQ. Okay, so if you want to define K, in this case it's only one. So the K here refer to more than one nearest neighbor. So for example, if k equal to 3, then we say 3 nearest neighbor. So we pick the neighbor, 3 nearest neighbor, and then we take the label, whichever is majority, we will put that label into the new item that we have. Okay, so over here we are saying that, okay, we take all the label that we have from 1 to k, where k is the number of nearest neighbor. So whoever got the majority will be assigned to the class label of xq. Okay. Okay. Sometimes they call it what is the best value for k? 1, 2, 3. Okay. Some people say that a square root of k will enough to produce good result. So if you have 100 data, then your k will be 10. Okay. So for example, like this, if we have all this ingredient here, and we have this sweetness, we have this crunchiness. No, this is, yeah. So this is the second feature. So this is the label that we have. Okay. So when we plot this one here in this 2D sweet versus crunchiness here. So if we have new item here, no. So that means we are grouping them into their own friends, nearest neighbor. Okay. But the idea now is that if we have a new item here, so we need to determine whether this new item belongs to vegetable, fruits, or protein. So how do we measure that? We use equivalent distance. Okay. So the advantage is the training is very fast because basically we don't train the model. Basically, they are taking the distance only. Okay, so that means during that night, when all this trying to pick one single item, so they will try to pick whichever is the nearest to the neighbor. So that one will be the label of that particular label that we have. Okay, so that means the training is very fast. We compute the distance. We don't lose any information, but the disadvantage is that slow at query time, because basically we are trying to compute all those distance. If we have 1 million data, that means we need to find the 3 nearest neighbors. Still, we need to compute 1 million times to compute the distance. Okay, so it also requires a lot of storage because you need to store all the sample that you have. Okay, so when we talk about how do we measure the distance between the new item and the data that we have in our data set, so we use called Euclidean distance, where this is the value for the first entity. So this is the value of the second entity. We take the difference, and then we take the square of this. So equivalent distance n equal to 2. So this one is 2. Okay. Okay. So before we can do the distance, we can also normalize our data by using range standard deviation. Okay. So for example, for the normalization, let me skip that one first. This is the normalization in which we try to have features that do not have bias on the data set, meaning that, for example, if we have salary and also age, salary will give you larger differences between the new item and the old item compared to the age, because the age is just a few single digit number differences between two person. Okay, so that's why we need to have to normalize them. So the first one is based on min max, and the second one is based on the mean or average or standard deviation. Okay. So in all cases, when we want to use K and N, we need to normalize them. Okay. So for example, if you look at the Euclidean distance here, so this is the formula. So we are looking at the differences between P and Q. Differences between P and Q. Okay, so that's why we minus everything, find the differences, and then we take the square, and we do it for all the features that we have in your data set. And then you sum up all those together, take the square root, then you get the value. Okay. So suppose we have this tomato. So our task is to decide whether they belong to fruits, vegetable, or protein. Okay. And the value for the tomato is, for sweetness is 6, crunchiness is 4, and green bean is 3 and 7. Okay. So this is quite straightforward, because we just take the value and then take the difference. For example, like this, if you compare the tomato with the grape, so basically you need to look at the differences between these two. So for example, for sweetness, this is 8, but for the tomato is 6. So we take the difference, take the square. Similar to this, we have green bean. Okay, no. We are looking at the crunchiness. So the crunchiness refer to this one again. Crunchiness 4. Okay, minus 5. This is 5 lah. Okay, and you take the square and then sum up with the first one and take the square. Okay, so this number here tell you the distance between two items that we have. The smaller the value, the nearer they are. Okay, any question? Okay, so based on this calculation, the tomato, if you use K equal to 1, so that means the nearest one is this one. Okay? So that means it belongs to fruits. The class will be fruits. However, if we have to take 3, K equals to 3, that means we have fruits, veggie, and fruits. But the majority is still fruit. So we will say for K equal to 3, then the nearest number are the nearest value will be 1, 2, 3 will be still fruit. Okay. 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 So the issue with this K and N is selecting what is the value for K. They said the best K will be the square root of the number of samples. Okay. What happens if you choose less or bigger value of K? Okay. There are terms like underfitting and overfitting. It's stated here that having larger K will cause underfitting, which means that during the training, it perform poor, but perform well during the testing using the testing data. Okay, so basically, when we have larger K means we have more nearest neighbor that we need to cover. So if you look at this one, this is underfitting. When you have more K, that means you need to fulfill all of them. So you tend to do straight line. So when you have a straight line here, so that means your during the training session, you will perform poorly, but you perform well during the evaluation. Okay, so the idea of classification is we want to have a close percentage between the what we call it during the training and also during the testing. We don't want to have two different results that we get. We also could have a smaller K. Smaller K means your line will follow the over here smaller K. So smaller K means you imagine this one is trying to go to the right position because they only have a few what we call it sample that they need to fulfill. Okay, so in the overfitting means that during the training your accuracy is good, but during the testing your data is not well performed. Okay. Okay, this is what I mean larger K. So if we have larger K, that means your line tend to be straight. When you tend to be straight, so your training session will be low accuracy, but when it comes to the actual testing, your accuracy will be high. So that is underfitting. Okay, but if you have a smaller K, that means you will have overfitting. So overfitting means during the training high accuracy, but during the testing low accuracy. Mana sudah kita. Okay, so so when we try to compare between two nominal or ordinal value, we just say if they are the same, then we put 1. If they are not the same, we put 0. So because this one is compare the two features having categorical value. Okay. Okay, so can an algorithm are considered lazy because we don't have to train them. Basically, they just have to compute the distance. Okay? So since they are not training, that means the abstraction and generalization will be skipped. And this lazy learning is also called instant-based. So if you seen this one before, instant-based learning is the same as nearest neighbor. Okay. Okay. So there is another issue that we need to look into is that the number of features that we have in our data set. Okay? So nearest neighbor is easily misled with high dimensionality of X. So easy problem in low dim, hard in a high dim. Okay, high dimensional, low dimensional. Okay? So these are some of the examples. We need to have normal distribution. We need to have point of hypergrid. We need to have a volume of hypersphere. So all of this must be um, completed before you can proceed. Okay. So when we have a lot of data, when we have a lot of features, then we need to do some feature selection. So feature selection we have two. One is filtering approach, and the other one is wrapper approach. Okay, so you have learned this one before, info gain. So we select feature that will split the data that maximize the info gain that we get. Okay, for the filtering, so the difference between filtering and wrapping is that in filtering, we have this space of feature subset. So we will look at if we use that particular feature, are we going to increase the what we call it, increase the classification tasks. Okay? So they will go around here, around here. So basically, in a filtering approach, the machine learning algorithm is separately from the algorithm used to find the nearest neighbor. Okay, so if you compare with this wrapping, so basically the machine algorithm that we have here is the same. If you compare with this, so the all the work that you've done before in the training set is separate from your testing. Okay, so for your training, there are different algorithm used. This is different from this. Okay, but if you look at the next one, the wrapper, the machine learning algorithm will be the same, because this is to avoid inconsistency. So when we do like this, that means automatically it will fine tune your algorithm to find the best TV set or the comparison between what will be the accuracy if you use this and this one. Okay. So how do we? Okay, this is feature selection. So feature selection means we select few of the feature that we have. We also can use feature weighting. So feature weighting is basically we put the weight, or we prioritize which column should have bigger weight, okay, or higher what given first priority given to the compared to the rest of the feature that we have. Okay, okay, so let's take a look at how do we use the KNN in order to perform classification. Okay, in this example, we are using the breast cancer. Okay, so over here we have 32 features, and one feature is the ID number. So For the ID number, we don't need because that one carry no meaning. We also have the cancer diagnosis, whether they have cancer or not, and the rest of the feature we have 30 numeric value laboratory measurement. Okay? So we use these 30 numerical values in order to find the K nearest neighbor that we map or evaluate against the new item that we have. Okay, okay, so this one is reading the file from Wisconsin breast cancer data. So we read, okay, so we will have this. So all the, but this one is string as factor false. So that's why this one is a character. So we need to change them into label. Okay. So we throw away this one because this one carry no meaning. This is just ID. So basically here we are saying that we remove the first column and we update our data set. So now if we look at the structure of our data set, we only have 31 variable only. Okay. Okay, next one will be, we look at the distribution of the cancer. So this is benign and malignant. So this number tell you the number of record that belong to benign, and 212 record belong to malignant. Okay, so malignant is the infectious cancer, and benign is not harmful cancer. Okay, okay, so since during the input we did not put this one string as factor, so that's why your diagnosis here is also character. So we want to change this one to factor. So how do we change them into factor? Okay, so first we look at what is the content of this diagnosis, and then in this one we are saying that we are creating a factor that consists of C and D. Okay, no, between B and M. C is the column binder only. So when we do this one, basically we are changing B and M into this. So benign and malignant. Okay. So that is our data set. So if you look at the proportion will give you the percentage of each of the type of the data that we have. So for the benign, we have 62%. Malignant, we have 37%. Okay. Okay. So this one tell you the mean value for smoothness, the mean value for area. So notice that this number are too big. The difference are too big between these two. So we definitely need to normalize them. So we use the min max. The min max is used to normalize the value that we have. So for example, if we normalize this 1, 2, 3, 4, these are the value that we have. Okay. So if we are looking at this 10, 20, 30, 40, 50, so the answer will be this. Okay. Okay. So now what we want to do is we want to do normalization. So basically we are applying the normalize function for all the column from 2 to 31. Okay. So this one will normalize our data in the R. Okay, now we divide them. Basically, we don't need to divide them into training and testing because KNN is just they use the k nearest neighbor, but it's okay. So for this one, they said, okay, from row number 1 up to 469, you will set that one as your training data set, and the remaining of the data will be put in the test data set. Okay. Okay, so the other one is that we need to look at the label. So the label for the training and also for the testing should be used later on. Okay. So to run the KNN, we need to install the package class first and then upload into the memory. Okay. And then we perform the classification here called KNN, and then we get the training data set from the training here, and also we have the test, and also we have the class where you store the class, and k is 21. How many times you go into the loop in order to find the best k nearest, the best 21 nearest neighbor that we have. Okay. And this one, okay, this one is just to look at the differences between if you use 21 nearest neighbor or the 10 nearest neighbor. So of course we will have different accuracy, different level. Okay, so this one is just do the plotting of the x and y, where we look at the test level and also the test prediction versus the actual test level, and also the actual test for the breast cancer. So if we look at that one, so this is basically this is correctly classified. This is no. So the error is, what is the error? 2 out of 100. Okay. So the error here is this one. Okay. So so the error for this one will be 4%. So this one is using k equal to 21. This is k equal to 10. So notice that the error that made here is different between these two set of classifiers. Oh, finish. Okay. Any question?
No question, doctor. No question.
Okay. Hanan, must be very tiring. After this lecture, we will have, I think, 2 or 3 only. 2 or 3 only lecture. So this is the 9 lecture. So nanti, I think Hanan still here. So nanti Hanan, you try to catch up lah. So I'll be putting up some more assignment and some more. Okay.
Okay, doctor. Okay.
So we stop here first. So we'll continue again.